Seventh graders. Today we're going to talk about finding the total number of possible outcomes for something, or also something that you'll hear referred to as the fundamental counting principle. And so this is just kind of like a shortcut to figure out the total possible outcomes of a series of events. So I'm going to use some examples for using locks and combinations and passwords to start, and then we'll look at how we can apply that to other ideas as well. So if we have a lock like the one pictured here, all right, we have 3 wheels. Each wheel is numbered from 0 to 9. And so if we think about the total possible outcomes there, the least 3-digit combination possible would be 0, 0, 0. So that would be one possible combination. And the greatest 3-digit combination possible would be 999, which is then actually going to give us 1,000 possible combinations. And the reason it's not just 999 is this 0, 0, 0 is the 1,000th combination. So there's 1,000 possible combinations on a lock like this. So using that same lock, we're going to talk about the possible outcomes for each wheel itself. And so we can think of each wheel as being its own like event. Okay, and so for the first wheel, we have 10 possible outcomes for the first wheel. I can do a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, and then for that second wheel, same thing. I can do 0 through 9, which is 10 possible outcomes. And then for that third wheel, I also have 10 possible outcomes. So we already figured out that there's 1,000 possible 1,000 possible combinations. So now let's think of how can I get 1,000 using multiplication with this information that I have. And so what we can do is we can figure out the possible outcomes for each event. So again, if we think of the first wheel, the second wheel, and the third wheel as their own events happening, I have 10 possible combinations, possible outcomes there, 10 there, and 10 there. And actually, if I end up multiplying these, that's what's going to give me that 1,000 combinations. So if we look at C, if I look at this dial lock, which is similar to what you guys have on your lockers, says this lock is numbered from 0 to 39. Each combination uses 3 numbers, so I'm going to have 3 events happening. How many possible combinations are there? And so when I think for the first number, I can have a number between 0 and 39, so there's actually 40 possible outcomes because 0 is the 40th number there. For the second number, I could have another 40 possible outcomes, and for that third number, I could have 40 possible outcomes. So if I multiply 40 times 40 times 40, it's going to give me 64,000 possible combinations on a lock like that. And then if I look at this last one, this lock has 4 wheels, so I have 4 events. So anytime it tells me how long the passcode is or how long that combination is, that's going to be, I'm going to put that many lines just to kind of help me keep track of how many possible outcomes I have for each one. So wheel 1, it has to be a number 0 through 9, so there's 10 possible outcomes there. Wheel 2 has the letters A through J on it, which is another 10. Wheel 3 has K through T, which is another 10. And wheel 4 has 0 through 9, which is another 10. And so if I multiply those 4, 10 times 10 times 10 times 10, I'm going to actually end up with 10,000 there. So that wheel, that particular lock would have 10,000 possible combinations. We can also, this works for passwords too. So when you think of when you have to enter a password into a website and it tells you that, you need 1 capital letter, 1 lowercase letter, 1 digit, 1 special character, all of that stuff. That's because it's trying to increase the number of possible combinations that you would have. So here the password must have 4 digits. Anytime you see the word digits, it's going to be a single digit, like 0 through 9, a number. So if I have a 4-digit password, I have 10 possible outcomes, so 0 through 9 for the first number. I have 10 possible for the second, 10 for the third, 10 for the fourth. And if I multiply those, I get 10,000 possible outcomes there. Here, the password must have 5 digits. So same idea, because it's using digits. So 10 possible outcomes, 10, 10, 10, and 10. And if I multiply those, just by having 5 digits instead of 4, now I have 100,000 possible outcomes. When we look at this one that says the password must have 6 letters, and we're actually going to do this one 2 different ways. So if it's not case sensitive, meaning a capital A would be the same thing as a lowercase a, all right, I must have 6 letters. So if a lowercase a is going to be recognized the same as a capital A, I'm going to have 26 possible outcomes for that first letter, all right? 26 for the second, 26 for the third, 26 for the fourth, 26 for the fifth, and 26 for the sixth, all right? And so now I'm going to multiply these, and we're going to see how just using letters is going to change our number of possible outcomes. And so when I do that, I'm going to get, I had to type some numbers in on my calculator, sorry, 308,915,776 possible combinations just by using letters, okay? Because there's 26 possible outcomes for each one. Now that's if it's not case sensitive. If we were to say case sensitive, meaning capital A is different than lowercase a, oops. Let's look at how that changes that number. Some people think it just doubles that number. But now, instead of 26 outcomes, I actually have 52 outcomes for each one. Because I have all lowercase letters, which would be 26 possible outcomes, and all uppercase letters, which would be another 26. So if I multiply 52 times 52 times 52 times 52 times 52, you actually end up with a really huge number. And it's not just double. It's going to go into our billions here. Give me 1 second. You should end up with 197,706. All right, so 19,770,609,660 possible combinations just by if it's a case-sensitive password, okay? So let's look at how we can actually use this with some other types of examples. So here, let's say we're ordering some bed sheets. We can get them in 5 different sizes. Sorry, our sizes, we can get twin, twin XL, full, queen, or king. And so when we look, there's 5 possibilities for the size, and then the style, I can either get them solid or patterned. So there's 2 possible styles. So what I'm going to do is each of those is its own event. And so there's 5 possibilities for my size, there's 2 for this style. And so to figure out my total possible outcomes, total possible combinations of different ways I could order my sheets, I'm going to multiply 5 times 2 and get 10 possible combinations there. Or 10 possible outcomes. So here, use the fundamental counting principle to find the total number of possible outcomes. So similar to what we just did using that multiplication. All right, here we're going to order some photos. There's 3 different options we have. We have size, finish, and edits that we can choose from. And so when I look at my size, I can get wallet, 4x6, 5x7, 8x10, 11x14, or 16x20. So when I look at that, I actually have 6 possible outcomes for the size that I could order. For the finish, I can get matte or glossy, so I have 2 possibilities there. And edits, I have red eye, black and white, or crop, so there's 3 different types of edits there. So I have 6, 2, and 3, and if I multiply those all together, 6 times 2 is 12, times 3 is 36. So there's 36 possible combinations or outcomes for the way that you could order your pictures there. Same thing for if we look at the laptops. We have a hard drive. You get to choose from those 3 style HD or LCD, and then color black, white, red, blue, pink, green, or purple. And so if you think of each of these as a separate event, I have 3 possibilities for the hard drive, 2 for the style, and for color, I have 7. And so I'm going to multiply those 3 times 2 times 7, and that's going to give me 42 possible outcomes. So the fundamental counting principle is just kind of a shortcut to figure out how many possible combinations or outcomes you can get. Have a great day.